Okay, so here's the data clean and nice. The first thing that we've done is to go to analyze dimension reduction factor analysis, and then you put all these factors together, right? All the way until the end. Well, I think we agreed that maybe credibility, we can leave it out, but let's keep it for now, all right? And then this is very important. And then, okay, this will take us only 2 minutes. It's a nice transition to. But before that, I want to also show you a little bit of analysis. So now, here's the results. You have very beautiful results here, 0.9, the higher the better. I have a piece of writing I'm going to pass on to you. This is significant, so this is really great. Over here, not any general factor has a loading over 50%. So the highest you have is 38%. That explains the total percent of variance. So none of these factors explain 50% or higher on its own. And all together, they explain about 70% of the cumulative variance. That's also very awesome. One of the things you need to report in your thesis is the initial eigenvalues, and it is just a list of each factor. You name them. You name them, of course, based on these loadings of the pattern matrix. For example, factor 1, you already know it's a brand fit. So you say factor 1 brand fit. Oh, you don't have to say factor 1. You just say brand fit has this eigenvalue, blah, 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 has this eigenvalue, has this all total variance, and the whole model or all the constructs have a total or explain a total of 70% of the cumulative variance.
So this is what I mentioned in the exploratory factor analysis.
Yes, this is how you report them. Yeah, I will send to you once I'm done with the certain writing. I will share with you a certain writing so that you can follow its lead. And over here also you have to focus on this results. This is awesome. It is over 0.7. Actually, it's over 0.8 even. That is really awesome. Over from 0.7 to 0.8 is medium quality. Over 0.8 is really awesome. 0.9 and above is like superb, I'm telling you. And this is also significant. So that's awesome. You just need to say this and that, and this is how you report these results. Now, reporting this pattern matrix, excuse me, you have two options, Anna. Mm-hmm. You could, I saw in some research paper last night, I saw that the researcher was not suppressing the values up to 0.3. They were suppressing the values up to 0.4.
Okay.
They have some paper that they referenced, I don't know. But mostly we suppress the values for 0.3. Let me just get rid of this floating diagram. So over here, when we do suppress the values to 0.4, we have less noise.
Very clear, yeah, a lot cleaner.
Yeah, a lot cleaner. And this means also a better convergent validity. I'm going to talk about the convergent and discriminant validity and reliability in a bit. So you don't have the cross loadings, but you may lose some loadings. Mm-hmm. So over here, you lost info 1, and also you lost info 5. Mm-hmm. Compare this. I like to use Excel for a reason. When we compare them, we can make a better decision. Yeah. So you can take a look here and put this together, because reporting results is more confusing than getting the results per se. After this point, I don't think you need anything. Maybe these ones, you might just take a look at these, the component correlation matrix, just to take a look at it. Now, let's compare this with the other one. I just want you to be really understanding what's going on. I myself need to try multiple things before we, I myself a little bit also careful, because I know Professor Tajidini is like a shark in this area. It's his game. He always publishes papers based on this method. All right, take a look. Let's take a look here. Anyway, we are going to delete this for a very horrible reason. Double loadings elsewhere. Anyway, do you see that? It's not loading on the corresponding factor. So this is okay. Second, this guy, it has cross loadings. I'm not going to call it double because it's more than 2 times. It has a cross loadings everywhere, here 3 times. And also, this loading is not higher than any of these loadings. It's a 3.9. Oh yeah, it's higher. Okay, you can get away with it, honestly, if it's higher. So this is one of the things you need to know. And I think you already knew from last time. If the loading here on its corresponding factor is higher than other cross loadings, then it's not as bigger problem. So maybe you can keep info 5. If you keep the 0.3. Most of the researchers opt for 0.3, really.
Oh, that's a good standard, 0.3.
Right? It's a good standard to keep going with what the others are doing. Because only one researcher last night, I just came across their paper and they were talking about 0.4, but they didn't even mention the reference. So I really didn't like their way, but they got away with it and they published. So if it's not acceptable, it would have not got published. But in any case, if you want to keep this guy, so I suggest not to report your analysis results yet. Why? In future research, in future analysis, in the confirmatory factor analysis, if we feel we have to delete this anyway, we probably won't even mention you probably might opt for, maybe in the thesis it's all right, but in the paper I might opt to just to choose the 0.4. It's up, there's flexibility, but in the thesis it's up to you what you need to do. So these 2 problematic ones, now we sort them out. Here everything is all right. Here everything is all right. Here everything is all right. Except for this guy, we're going to delete this guy anyway. This has a problem, but actually it is higher loading here. So I think we already discussed this and we don't have any major problems, right? Did we?
Except credit and expertise load into the same factor.
The same factor, this is a problem, yeah. Credibility here, 3.8. You see here's higher loading. This is a problem here.
And it loads into the same factor as expertise.
Yeah. And similarity and expertise here. Oh yeah. But if we get rid of credibility, we are faced with another problem, or we don't have any problems. For the credibility, we can impute the scores. So I'm going to talk about imputing the scores later. You will learn more about it and you will understand why I'm saying let's try without it. Do we have any major problems without it?
No, just some double loadings.
Just double loadings. Oh, perfect. But we don't have 2 of them loading together.
No.
Yeah, that's perfect. This is why other researchers were not asking the question about the credibility. Okay, perfect. So we have this perfect. No double loadings. Okay. We discussed this last time, so I'm not going to waste your time. This is a problem here already. This is not a big problem because the loading here is higher. Over here, perfect and high loadings. Over here, these are lower loadings, so it's okay. Over here, these are fine. These are fine. Guy has lower double loadings, but these double loadings are way much lower. Okay, over here, good. Over here, similarity is good, but we have here double loading here and double loading. This is a problem here. Attractiveness here, this one is a problem. So we probably need to delete, not probably, but we need to get rid of attractiveness 4 in our pattern. in our, now when we are doing the confirmatory factor analysis, let's keep in mind that we are going to delete info 1. Okay. Keep in mind, all right, if in case I forget. And this one, we keep it. This one, we can't keep it. Good thing that we have 3 others here. It's good. And over here, similarity is all good, because this loading is way much higher also. Over here, we have
social one. It's also an issue, right?
Which ones has a problem?
Our social one, because it loads a lot higher in
here. Okay, so this one has a problem. We're gonna remember to delete it or eliminate it from the subsequent analysis. What one also? 125. This one I'm gonna keep, right? It's higher here.
Yeah.
Maybe we need to get rid of this one. Oh my. Just little, right? Just a little. Hey, loading on what? Loading on similarity, huh?
I think this one is something like, if I remember the question correctly, it's something I can easily identify or something. No, or it feels like, oh, I want to move this person in person.
Really, it's totally completely different meaning than similarity then. Let's take a look. Have you had access to this file?
Yeah.
Good. Let's see here.
Parasocial 3. Oh.
Okay, I see. Could be similar to similarity because she understands the things I want to know. So it's in a way similar to me, right?
Yeah.
Okay, no problem. We have so many questions, other questions. Don't feel upset, please. We are just doing very well here. So let's agree now that these guys are gonna we're gonna tell them goodbye.
So in my thesis, I would first go through the pattern metrics, including credibility, in order to make an argument why I kicked it out afterwards, right? Just excluding it from the beginning would be a little.
If you want the truth, right from the beginning, I didn't like the questions for credibility. Do you remember? I told you we can't ask these questions because, okay, questions that we asked about credibility is basically the same titles and content as the other questions. Like, is this similar? Is this not similar? I hope that I have them here somewhere. I don't have the credibility here.
Yeah. Go down.
And these questions, we asked about similarity, for example, but similarity is not identified directly. We through research and theory, we said that this is a latent variable or a factor that's unmeasurable, unobserved, and it is measured through these observed questions, observed measurements. So for us to ask this question as part of measuring credibility, while we said already that this question, we didn't put any question, I am similar to him, he's similar to me, because we don't ask this way, because the similarity is a construct that is latent. So in fact, we will look so silly. I'm sorry to say that, but at the very beginning, I didn't want to say no to everything. There's the number of no's that I can tell is limited also as a supervisor. And I told you, okay, let's do what you want to do also, because you're doing a good job, and I don't want to say no, negate you all the time. And collecting more data is better than collecting less data. And it's good because now you can see why I was a little bit conservative, because even the results and the analysis has showed you that it's a mess. Some of the questions loaded higher on others, on other factors. This is also problematic. Here, credibility, but the first question, it's the first question I have confidence. Let's see. First question had the problem, and the second question, the remaining two questions didn't have a problem. And the first question was confidence, and the second question, valuable opinions, which is the valuable content thing. Accuracy, communicate effectively. I like these two questions. I really like these two questions. Communicate effectively and accuracy. Can keep credibility.
I think, but it still loads into expertise.
But then we can keep it with two questions only. This is a problem.
But it's still in the same component of expertise.
Ah, is it?
Yeah.
Is it? Oh, sorry. Oh, okay. I missed it out. Oh, okay. You have so many factors. Oh, thanks for pointing this out. This was the main problem, right?
Yeah.
Okay. I see now. But you know something? You know something?
Maybe we can shift those two as
Yes.
more factors for expertise instead of calling it credibility.
Yes, indeed. Yes. And let me tell you how we make this the very difficult decision. Let me show you. We go to analyze, the second step, and we go to scale, and we go to reliability. And over here, to expertise, right? You said?
Yeah.
Put expertise alone. And let's put here expertise, 4 factor, 4 items, all right? And hit OK and get the Cronbach alpha. Cronbach alpha here is 0.8, which is really awesome. I'm telling you, 0.89 is awesome. Let's see what happens when we add the other 2 credibility ones, 3 and 4. Is actually reduced.
Yeah.
0.89. But nonetheless, how about we do that? Because you collected data and I love the questions. Don't you like the questions? Don't you think that these questions are important? Like communicate well is part of the expertise, and also the information is accurate.
Mm-hmm.
I think we shouldn't be disposing anything. It's hard work, and we shouldn't be disposing anything. I suggest, despite this, it's still a very good Cronbach alpha, right? Did you find all the Cronbach alpha?
Mm-hmm. I put them in the
all were
OneNote.
You already did?
Yeah, I hope it's safe. Yeah, it's safe.
Oh, perfect. Info value 0.7, all of them over 0.7, huh? Oh, look at this beauty here, 0.9.
These are the European millennial factors all together in one. So I don't know if that's correct.
Yeah.
There.
We don't need to put them in a factor. We don't need to put in a factor. It's okay. Okay. All right. Good. So we can proceed now, right? But one step I would like to also point out, since we are still on SPSS, is to go to regression and go to linear. And do you see here the serial number that you have? I always have a serial number. Put it as a dependent variable here, and then put all the variables that you got as an independent. By the way, we forgot these guys also. The purchase intention. Okay, and now let's just make sure that we have the collinearity. And we check the VIF. Okay. None of these should be over 3. Here's another problem, info 2. Anyway, info 1, we said we are going to get rid of. So let's get rid of info 1. We said we want to get rid of first. multicollinearity is one of the assumptions necessary for regression. And whatever we're doing here is, it's a method, the structural equation modeling is a method that is based on regression and on path analysis. So over here, we need to care for the main assumptions of regression. Info 2, which ones we said we're going to get rid of? Info 1.
Fact 4.
Fact 4. We just need to be a little bit patient. Attract 4, we're not going to take.
And parasocial 1 and 4.
Okay. Okay. Because the VIF might change, in fact, with the absence of some of these. Let's see. Almost a 3, but it's not 3, so it's okay. Uh-oh, here we go. Here's a 3 here, fit 1. No, no, the fit has so many over 3, but listen, there is a reference that I have from the literature that says below 5 is okay, but most of the papers say below 3, but I want you to know that the bestest is below 3. However, there is a reference paper from the literature says it is okay if it is below 5. All right. And some even go far extreme and say below 10 is okay. Some researchers, you know, they go so far saying below 10. In my case, I aim at below 3. In case below 3 is not attainable, and I'm going to lose a lot of variables here, I'm going to just say below 5. And we are lucky here. We don't have that much below 5. Oh, we have here, these guys.
Trust all of them.
All of them. Okay. Anyway, multicollinearity is not that big of a problem anyway. And there is a way to fix it. It won't hopefully get us. Why do we take a look at all this? Because sometimes this might be the reason why the analysis might be a little bit difficult or not give us the results anticipated. Another reliability check that we look into is analyze, I think, regression, or which one here, descriptive, and was it explore? And we put here this one. And we put all the variables that we want here. And we need to reorganize the variables so it's easier to shuffle them. Which ones we said we're going to delete? Attractiveness 4.
Yeah, and parasocial 1 and 4.
And the credibility, of course. Also, one piece. Okay. This kind of analysis here. Where's the results? Still getting us the results. Gives you the, take a look at the outliers. So over here, I have 2 outliers here. You see that? I maybe can get rid of these. 198 and maybe 187. We probably might decide to get rid of this outlier. Where are the rest? Okay. There's one more. If you check scale and the scale of item deleted, if you check these two while doing the analysis for reliability here, but by adding all the factors in there, I will show you. Entertainment, all of them. Expert is all of them, right? We're not deleting any.
Yeah.
Yes, okay. Similarity is there. And parasocial, we're getting rid of 4, right?
Mm-hmm.
And then if you do this, you will get something here called corrected item total correlation. So the corrected item total correlation here, it should be greater than 0.2. This is more important than the VIF. Oh, lovely. I had to delete one of my factors because it was below 0.2. And all of them are actually higher than 0.4 even. Oh, here, 0.2. Okay. Okay. So that I care about this really more, the corrected item total correlation. This tells you how good the question is, like if the question is asked in a nice way, in a good way or not. So this tells you more about the question itself, the question if it's been asked and correctly. So this is really nice. I like that. So once this is checked, is okay. The only thing that is a little bit upsetting to me, it's a downside because I like to report as many good results as possible. But since our VIF aren't that promising, like it's not something that we are very happy with, you don't have to report that. Unless Professor Tajuddini asks, I hope that I will still remember. But if he asks, we can just say, we have a couple of them about 5, but all of them were below 10, and some researchers say below 10 is all right. Okay, here, the VIF. I don't think he will ask such deep, in-depth questions. So we have all 0.6 and 5 here in the trust components, huh? Listen, I will work on it on my own, yeah? Or right now, would you like to check? I want to delete this one, drop this one, trust 4, and see what happens. Sometimes when you drop the one that has the highest VIF, the rest will have less values of VIF. I'm just going to show you very quickly, but I'm not going to waste our time today on investigating this. So the one that has the highest VIF was the last one, trust 4. So I'm going to get rid of that as if it's not there and see the answer, see the VIF values. Okay, still we have, you see now with the trust, we have 1 has 5, 3 has less. So seems like if you delete like one of them again, which is trust 1, you will have both of them below 5. But the problem is you're going to have less than 3 components together. And I don't like that. In research, in this kind of research, the minimum number of acceptable components should be about 3. So for this purpose, we're just going to go by not reporting the VIF because it isn't that great. But if we are asked about it, we just report it as below 10. And I think there would be a reference for that. Once there is a reference, you get published, so it's okay. All right, let me save this. So this is the total exploratory factor analysis, the total report. So we had the Cronbach alpha, we had the corrected item total correlation, right? And the VIF for multicollinearity also.
Do you have like, because that's the first time from doing and also hearing most of this stuff, to be honest, like I've never heard it before.
Mm.
Do you have like a paper or something where, you know, like I could take for reference, like what actually needs to be reported and what each of that is also?
Yes, sure. I will compile something for you and put it together and send it to you. Yes, why not? I'll send you right away. So now, what did we agree on? The last thing we agreed on. I want to keep remembering what we agreed on. There's no info one in our factor analysis, right? Right?
Which we then put into the CFA.
Yeah, and we said we are going to get rid of expert for or attract for, and the parasocial 1 and 4.
Yeah.
Okay. Anything else?
I think you have to enter add the purchase intention.
Yes, Anna. Yes. Good. Saving our time. Okay. All is good? Yes. Perfect. Even better. 74 now. And here's your pattern matrix. Okay. So now let me go again to the beginning of today's session. This here, the pattern matrix builder, when you get it, you download it. I'm just going to show you very quickly. The first thing you need to do and keep it, the first thing you need to do is to show in folder, right click and go to properties. I'm recording, so it's okay. I'm going to share with you the link. And then check unblock. Once you check unblock, you copy that. And then you go to the C. Make sure on the view here, you check hidden items so that you can see everything. And then go to users, go to your user, and then go to, if I remember correctly, app data. After app data, go to local. After local, go to AMIS development, and in AMIS, I had 26, now I'm on 28, and go to plugins and just copy that in there. I already have it. You see the pattern matrix builder, and I have many other, some other. I also like the resize one, but the pattern matrix now is a very important one. Okay, so get that and put it in this folder. And then when you are, after downloading AMIS, of course, and now with AMIS here, the first thing you do is, it's going to be a blank page. You want to create the model. So you go to plugins and you go to the pattern builder, specify the data file. That's correct. I'm going to specify the data. So where do you you connect this file to a data source? You go to this, select data files, and go to the file name. And then you go to the, and this is my data, not yours. Okay. Over here. What was the name of our data set? Yes, it was data set, and it was the clean one. Okay. So here I selected the data set, and then I go to the plugin and I go to the pattern builder and copy. Okay, it wasn't here. Go here, pattern matrix, copy that. You go to AMIS, paste that, you see? And then create diagram and wait for it. Look at this beauty. Created everything for you. You see that? Alternatively, if you needed to create this structure over here, you would have to use this, draw it, and then click inside, and then rotate it. And after rotating, you can move it, of course, by going this way, and you move the whole structure. I have a video for that. You move the whole structure by clicking onto this point, into this icon. Please watch my videos. And then you need to pull out your variables data set, and then go from scratch and and add info 1, info 2, info 3, and so on. And then after you do all this, you have these unnamed. You have to name them. There's a plugin for that called Name Unobserved Variable. So these are named now. You can leave this as is, but it's not meaningful. So you have to right click on this and then say, instead of F1, I'll call it info and underscore quality. Don't keep any spaces. Spaces will make will not the AMIS analysis will not run. In the labels, it's okay, you can keep spaces, but in the variable name, no spaces. Okay, so and this is how you do this. And after you do this, and again you do another one, you have to use these covariance lines to connect all the latent variables together. It's a horrible process. Now I'm going to delete all of these. I don't need them because I have this smart plugin that I suggest that you use it. It will save you a lot of time and effort, really. So now we have all these guys together, right? Mm-hmm. The only thing we need to do is to name them. Let me do that since I'm going to be using this again and again. I'm sorry, I have this itch that I need to have everything nicely lined up. Okay, so you need to, first of all, select, right click, and then what do we name this? You know what? I'm just going to copy this and put it as a label. And here it is. The second one, trust, right? Just call it a trust. I know it's a trustiness or something like that, but it's okay.
Trustworthiness, yeah.
Trustworthiness, yeah. And we have here expertise. Then it takes time, but be patient with me. Here, entertainment. Then 5 is intention to purchase it. Oh, I'm leaving spaces. This will give us a lot of trouble later. We don't want to waste our time troubleshooting silly stuff. And here, what's next? Similarity. Mm-hmm. So this gives you a lot of time, this plugin. I highly recommend that you use it. And here, attractiveness, almost done, almost done. Info, right? Info quality, something like that, was it?
Information value was the name.
Value, okay, sorry. Sorry, I know I'm working on 2 other projects. Okay, you see what happened? Something very horrible happened. Do you see information value here? Instead of here? Seems like I selected the wrong item. Something like this could happen. Be careful, okay? Sometimes AMIS is crazy. So we need to be somewhere else. What's going on? In this case, just use this hand to unselect everything and go back again. This is supposed to be 9. Okay, is it 9? Yes, it's 9. Now we're fine. And this value. I'm going to reshape these a little so we can see them. See that? Okay. Now, we can actually write this as trustworthiness if you want, but later. But I'm going to make it bigger for now. Save. I'm going to save this inside your folder. Data analysis, and I'm going to call it the measurement model. Okay. We call this the measurement model. What is the measurement model? The measurement model is basically this construct, which is a latent variable called the brand fit, measured by its items. We call these items, items or observed variables because they are observed. We ask the questions about them. And we call this the latent variable, or we call it the factor. You notice here, these we call them regression lines. One of these regression lines should be set to 1. You see? Over here, restrained. One of them should be restrained to 1. If you go to parameters, you should see 1 in the parameters. Here, for example, this one here. Expert 4, it's taking this one rather than taking the line. I need, sometimes it's difficult. I need to be very precise, even though here, aha, regression weight. Do you see that? This regression weight, you can alter it from here. You need to be a little bit patient, right? So if you are drawing things on your own, somehow, you need to make sure that there's 1 here, okay? These over here, we call them the covariance lines. And all these latent variables are correlated here with the covariance lines. Now, what is it that we're looking for? We're looking for loadings over here on the regression lines. In your case, I would say in research papers, they will say over 0.7 because they take their questions from other people and they are already tested questions. In that case, we a little bit manipulated the questions, right? And we have like a kind of newly introduced model. So in our case, we're going to accept up to 0.5 and above. Anything, any loadings below 0.5, we will have to let go and eliminate. All right.
Just one question. Those are different loadings than to what we did in the pattern metrics?
Yes. Yes, they are. Yes. If you've noticed in the loadings in the pattern matrix, we said suppress anything below 0.3.
Yeah.
Over here, we have to eliminate anything below 0.5. And there are 2 different kind of estimates or loadings. There is the unstandardized estimates that is not divided by the standard error. And then there's the standardized estimates, that estimates the weights that is divided on this over the standard error. We are seeking the standardized estimates. We look into the standardized estimates. Sometimes I get trouble. At the very beginning, I got horrible problems running this model. Sometimes it doesn't run smoothly. Not everything runs smoothly. So we need to be patient and I might have to troubleshoot with you. So we need the standardized estimates. You need to check this lovely button, standardized estimates. All right. One thing we need to look into is the tests for normality and outliers. With this kind of analysis, structure equation modeling, we care about multivariate normality, not univariate. What is she talking about? I'm talking about when we are looking at each factor alone, separately. We look at the normality of fit 1. We call this univariate. Fit 2, univariate. But if we're looking at the normality of the whole thing together, connected all together as one unit, we call this multivariate. Okay, so now let's run this lovely model. Let's hope that it's going to run nicely. So here we have the analysis properties, here where we set up the data set. And here we are just going to run the model, calculate the estimates. Oh my God, I'm so scared. Don't believe them. I do have a valid license. This kind of problem, sometimes it's just that it's not me alone. even with some of James Gaskin also has in one of his videos, he said, oh no, this is not real. I do have a license and I do have a license. Sometimes it happens. Please. Yes, it ran. You are a lucky one. I did have some problems, and I tell you the truth, sometimes it doesn't run smoothly and it gives me trouble. In your case, I am so happy it ran. Let's take a look, Anna. Over here, we have 1, 0.9. What are these estimates, Anna? These estimates are unstandardized. I'm not interested in this. Nobody's interested in this. We are more interested in the standardized. Do you see that?
I was about to say the unstandardized look quite nice.
We're actually even look, I can see that they are nice too. Let's take a look. Oh my God, I hope so, I hope so, I hope so. View, I want to make it a little bit bigger. And it's one of the things here. Let's take a look so that we can take a close look. One little thing that I like to, the move parameter, you see move parameter values? See them a little bit better, you know? Let's put this here.
Is that something you would put in the paper as like a graph?
The graph? Yeah. Put the graph in the paper, yes. Yes, of course. You need to show. It's beautiful. Can't you see that? These so far are all over 0.7. Congratulations. Next.
That's better.
Beautiful numbers. You are laughing. You should, because I am suffering with my other paper and I had to work a lot on cleaning data. Over 0.7, over 0.7, over 0.7. So far, so awesome. But look at entertainment. Entertainment is going to upset me a little. But you know what? We can let go, but it's almost 0.6. We can say it's almost 0.6. And this kind of questions, we put them together maybe, right? Let's take a look. If we put these,
we change them.
We change them, right? So
yeah.
Change the questions. We can just say we changed the questions. I read that in multiple references, okay? Then it's all right to be over 0.5. It's just a matter of a sample.
But I think we can be happy with Brentford because that's all stuff we created, like the top one.
Yes.
And everything is above 0.8.
Yes, and this is you put together in the model, right?
Yeah.
Yeah, this only the first step of many other steps to do. Parasocial is not bad.
Parasocial was all taken from the paper.
Yeah. Look, all taken from the paper, and they tell us it should be 0.7. Well, what can I tell you? Maybe our sample is a little small, but I'm going to say we don't have that many over 0.5. We mostly can say all of them are over 0.6.
But can we also say with parasocial, maybe because we asked a completely different target group than they did in their paper? Does also have an effect on it or not really?
I'll look into that. I don't want to answer very quickly. I'll look into that. Okay, let's look into that. But I am happy. None of these are below 0.5. So I'm happy. We can just say that we actually changed many of the questions. And the editor can easily see that we changed the questions. And trust me, the reviewer, if they are reviewing the paper and see the questions in the old style, like how they asked them, they were so relevant. They asked these questions and put all these questions before this very advanced method of analysis. And I'm sure if we took their questions as is, we would have had a horrible paper. Trust me. From my experience, this is why I told you we need to change the questions, and you agreed with me, and I'm glad you did. Now, the second thing we want to take a look into is these guys over here. We want these guys to be loaded as high as possible. The higher, the better. But over here, it's the other way around. The lower, the better. And there is a threshold here is below 0.8. Anything below 0.8 is okay. Anything over 0.8, then it's a problem. To say the truth, I don't to know how to fix such a problem if we have over 0.8, because I never encountered it. It's very rare that you encounter a very high correlation. If these guys showed that on the exploratory factor analysis, they are loading on separate factors, right? So if you're doing exploratory factor analysis and you already saw that these guys are loading on separate factors, then the probability that these two are correlated or the covariance here is high is also very low. Now we can't see these, can we? So for this purpose, we're going to hit to this button. This is where the view text output is. Here we go. So let's take a look. The first thing you need to do, and it's going to be upsetting actually, but I don't want to do it now. I'm going to do it later. Let's take a look at the estimates. The estimates here, we look at the standardized regression weights, and these are the estimates as you can see. But where is the confidence level? Where is the significance? These estimates alone mean nothing with no significance. Aha, so we need to click on the estimates up here, not on the standard regression down here. So just clicking on the estimates, you will get the p-value. And can't you see how beautiful this is? And trust me, not most of the time it is this beautiful. All of them are significant. So any of these guys over here are below 0.5, you have to eliminate it. Any of them, any of these loadings is not significant, you also have to remove them.
We don't have to remove anything, right?
Yes. Yes, you don't have to remove anything. So that is just fine. And this is done with the measurement model. Now, are we done yet? No. So this is the first step, the convergent validity. Discriminant validity here. And now we need to take a look at the model fit. Now this is where most of the trouble is, but not really. I have trouble remembering the thresholds, so I put them all together in one file. I'm going to put them on our OneNote. So first of all, we look at this one. This, we care for this one. Significance level, don't worry about it. So this here, over here, should be less than 3. Very good. We're almost approaching that. So that's good over here. Now, the second is the goodness of fit. Goodness of fit is not good. Your goodness of fit and adjusted goodness of fit is below 0.8. It is maybe acceptable because in the threshold, in this kind of method, we have like medium, accepted, very good, super, very good. So I need to review the different levels and the brackets. But usually we accept something 0.8 and above as is superb. But this is approaching the 0.8 also. The CFI, same thing, 0.9 is acceptable. Over here, it's a little bit 0.8. But you can just report them as is in your thesis, and that's fine. That's totally fine. This is your findings. You report them as is. We usually report this, the chi-square over the degrees of freedom. It should be less than 3. And I'm going to send you a paper so you can take a look at the way that they report. But every researcher reference a certain other researcher on accepting a certain reference, but not researcher like me and you, but researcher in statistics, that they've done statistical methods and they showed that this threshold is more acceptable than this threshold. So there are different schools of thoughts about the thresholds. So there's a bit of flexibility as long as you have the reference, if you find the reference for it. These guys, I have seen the 0.8. Then you have over here 0.9, you have 0.88. I'm sorry that it's not that great either for the TLI. 0.9 and above is like superb. This is a little bit low. And NFI here 0.79. Here, this is below it. This is very important. It should be below 0.08, almost on the edge. That's good. The B close is supposed to be really high. No. It's significant. Okay. This is actually also in one of the papers I read also last night. This is supposed to be over or below 0.08. Yes, I remember. This and this are supposed to be below 0.08, and you have them. So that's amazing. These other ones over here, these are for comparing models, and I don't think we need to compare models. The lower, the better. If you have two models, you take the AIC and the ECVI, and the lower, the better. But we don't need to compare models. So we just focus on absolute fit, and the absolute fit here is awesome for you because it is below 0.08, and this high bound is also below 0.08. That's good, and it's significant. And then one of the good things that you have is, I am sorry that these are not as good, but maybe we can improve on it. Let me work on it on my own. In any case, the normality assessment, I don't expect it to be normal because your data is not normal. Our data is discrete, is ordinal. It's not continuous. And normality is something that we apply on continuous data. And over here with AMIS, usually researchers in general say, the bestest researchers who don't want anybody to irritate them or refute them, and they want to go with the normality assumption, they say that this should be below 1 point, and the skewness should be below 2, absolute value of 2. So I can see now that you have really awesome data in terms of skewness. So you can, first of all, here, this is univariate normality, and over here, kurtosis. Let me explain. The normal distribution, do you know anything about the normal distribution?
Yeah.
It's like a bill curve, right? Yeah. It's symmetric, right and left like each other, right? In the center point, if you split the center. So the skewness is not skewed, it's not tilted right or left. The skewness, the normal distribution is what? Is 0. There's no skewness, it is so straight, huh?
Yeah.
Now, there's an acceptable level to skewness. So the tolerance here, some researchers say below 1. Some go so far saying below 1. Others say, you know what, and most of them say below 2 is okay.
Does this relate to like confidence interval and something?
No, skewness has to do with the behavior of the distribution of the data.
Okay.
It's normal, it has a bell curve. This curve not always looks nice like a bell. Sometimes it's skewed. Look it up in your native language. What is skewness? Like skewed, like Nora is standing up in a straight line, or Nora is tilting her hips a little.
Yeah.
A little bit tilted. So a very super normal distributed data have a skewness of 0. But honestly, even all researchers will tell you
it's impossible.
Perfect. Nothing is perfect. So there is a tolerance level that we could accept a skewness up to a certain level and yet consider the data as normal. Some researchers say below 1. And I have seen many other researchers say below 2. And I will tell you from my experience, those researchers who say in their paper, I go with this a threshold that's my skewness is below 1. It just happened that all their skewness, where they were lucky and it's below 1, they want to show, and it's their right to show that they are really tightly quality data. You got my point?
Yeah.
But most researchers accept and tolerate up to 2. So over here, I can see that you are awesome over here with up to 2. Now looking at the kurtosis, please be careful. I have seen some, I don't want to say a bad word, but some garbage on the internet about kurtosis. And I'm so in awe and surprised of people. Now, normal data, this bell curve has a kurtosis value of 3. It just surprises me when these researchers say skewness and kurtosis should be below 2. Man, if the normal distribution has a kurtosis of 3, you want to be more flattened than the normal distribution? I would say, or more or higher. So I would say with the kurtosis, also the results here from AMIS could vary a little bit from the results from SPSS. There's a way to find the kurtosis here in SPSS through analyze and explore the descriptive analysis. I think frequencies or explore, I don't remember exactly. Yeah, here, kurtosis and skewness. Do you see that?
Mm-hmm.
Continue and throw all these in there. So you will find slightly different. So I don't see also major problems with the kurtosis. It's within the three. Now, there's a second thing that you need to also know. So some very rare researchers look at the critical value. This is called the critical value. And this critical value, AMIS have a built-in function to compute this. And in very big data sets, like really very big data sets, sometimes some researchers say even this big data set is anything above 200, and our data is like 205. So it's around above 200, a little bit. They say it is really hardly possible to get a critical point that is 1.96. So anything below and equal to 1.96 is acceptable for critical value. But researchers, you rarely find them even talking about this critical value here, unless it matches the expected 1.96. First of all, because it is not attainable for bigger samples, and most of the researchers who have very good research, the minimum sample size is actually 200. So don't worry about this. I'm just explaining to you what you could encounter when reading other papers so that you don't really get a headache. Oh, I don't have this, I don't have that. So don't look at this CR. Now, you will tell me, Nora, you told me we care for multivariate normality, not the univariate, not this one, this one, this one. So why am I looking at the skewness and now why am I looking at the kurtosis? I tell you that's true, but it is just researchers that they report the normality. And over here, I can see that in one of the papers that I myself is referencing, they are accepting the multivariate here, the critical value here for multivariate to be normal, not on 1.96. This 1.96 is crazy. They have the 5 threshold, and there is a reference for it. I'm going to pass it on to you. Our critical value here is 38. It's way much bigger. So for this, I would say to solve this problem, and if you insist on the normality assumption, you would need to go to the Mahalanobis distance and find out if there's any jumps and further clean your data. Unfortunately, your data set is already on the edge of 200. I don't want to delete so many points, but I urge you to try to delete the first point here, has the highest distance away from the mean. Okay, let me explain again theory. Theory-wise, if anybody asks you, there is 2 approaches, and unfortunately, most researchers that you're going to read their papers, and even the research papers I'm going to pass on to you, they tell you, we cleaned up the data. Why? Because there's 2 assumptions, assumption of normality and assumption of no outliers. Have you taken any data analytics class in your master course?
I've taken like the Python class with Professor Vasily.
Okay, so you probably talked about cleaning data and outliers, maybe, right?
A little bit, yeah.
A little bit. Okay, so some researchers and some big number, they say we look at the P1 and P2 value, and mostly on the P1 value, and we delete all of the values that has a P value less than 0.05. Okay.
Mm-hmm.
So they're gonna go on and delete all these values at once. This is what they do, and they claim that they do up to here. You see this value here?
That will be quite a lot.
Please don't do that for so many reasons. from my own experience, once you delete all these and run the model again, let's say that you have a big data set, and revisit again this Mahalanobis distance, you will find out that you still have some new points up here. Yes. And again, you delete them, and again, you will see some points. And again, you delete them, and you will see some points. And then your brain is dead in a sense that you are just following a mere threshold. Where is the beauty of actually contemplating? What do you mean? Take a look. I take a look at both these guys, the P1, P2, because everyone reporting this. But in reality, we really need to take a look at the leap, at the distance in between. 121 to 93, you know how many units in between these? Massive, right? Big jump. So I believe if we delete this point, we're probably going to get better loadings over here, maybe, sometimes not. In my case, sometimes not. Well, this is where I stop deleting points and I compromise. And I say, you know what, I'm not deleting any further points because actually the model is not improving. These, we call them influential points. Why do we delete these outliers? We delete these outliers because we call them influential points, that they affect the model performance negatively. So if we take them out of the data set, the performance of the model will improve. Up to a certain point where deleting more and more points may actually have an inverse like a negative output or consequence. 93 and 87, a big jump. After that, do you see how smooth the lines are? 84, 83, 80. Oh, there's a big jump here also, 80, 72. 71, 69. Yay. But as you go down, do you see that it's more smooth? Here's 40, 41, 42, 43, 44, 45, 46, 47. Do you see what I'm talking about? 8, 49, 50, 51, 52, 53. They are all in the vicinity of each other. They are all one cluster together. 52, 53, 53, 50. Here, there are some leaps. Where is 54, for example, 53, 54? Now, I would do the following. First of all, listen to me, Anna, please. First of all, our data is never going to be normal. Our data is not continuous. Our data was measured on a not Likert, but an anchored scale from 1 to 5. It's discrete data, isn't it? It's ordinal data. We call it ordinal data. It's not continuous data. It's not a height. It's not an age. It's ordinal data. But researchers in social sciences and management can deal with this data as if it's normal. If these guys showing normality, but in our analysis, this method, our method requires multivariate normality. Some researchers go further and some researchers stop. Some researchers tell you the multivariate normality here is up to 5, the critical value, and that's it, they stop. And they say, that's it. And I'm gonna go with the multivariate normality. And they maybe attain this, the 5, by getting rid of these guys over here. And then they go ahead with the normality assumption and just go ahead with it. I don't mind this approach for master students, but for me, I know that my data is never going to be normal. Even continuous data is very difficult to find it to be normal. And honestly speaking, if we're publishing something and the reviewer is a bit of a strict person, and I might be one of these people also, and I like to avoid any misfortunes, they're going to ask us to plot a plot called the QQ plot. Let me keep this because I might send it to you. The QQ plot is something like this. And it is basically the, will be the Mahalanobis distance, and will be the chi-square. There is a way to do it, and I think I made a video, or I'll make a video about it. So let me put here, Mahalanobis distance and chi-square. Something like that. These guys plot the distance here and the chi-squared here. But in any case, the idea is when you are plotting the distance versus the chi-square, you need to draw a line. You see that? And these are going to be your line. And all these values on top of the line are considered outliers you need to clean up. Some reviewers might go farther and saying, you know what, this is not normal because you have a little bit, you see, on top of the line, and they might give you trouble. Something like that might not give you trouble. You just need to delete this guy here and probably these other observations because they are distant away from each other. But all these probably are right. But who knows? This is visually how to assess multivariate normality. So you have like the chi-square here or the distance here, and you have the chi-square here, and then you need to draw a line, which is like a trend line in Excel. But most of the time, my data never had this. Even this line is considered beautiful for me. My data always gets something like this, or something even crazier. So let's go back and try to delete this data point before I let you go and see how this will affect this reading over here. So it is 0.115. I am keen to deleting also and getting rid of 160. Or let's do 115 first, okay?
But you say it's like it makes the most sense to like aim for normality, or if we just say we don't under the assumption of normality?
It's easier for you as a student to go ahead with the assumption of normality. So I'm gonna try to get that number to 5. This is what I'm trying to do.
Okay.
So what was the number? The 115, right?
Yeah.
This one, right?
Mm-hmm.
Oh no, wait a minute. Oh no, this is 96. Do you see this?
Oh.
Yeah. So 115 will be this one. 115 here, right? Because you also clean the data here. And I'm going to save it. And now I'm going to go again and ask to upload the data one more time. And I'm going to run it and let's see what happens. But I'm very happy that it ran really nicely and smoothly and everything is below. You see? 0.49. Info 5. Anyway, info 5 was actually giving us trouble anyway in the factor analysis, I remember. Let's take a look. I'm going to do this on my own and check it whenever I have time. What was the number before?
34.
Yeah, so it improved just slightly. So in this case, I will suggest that we go for the bootstrapping method. And the bootstrapping method is a method that we use for non-normal data. So if your data is not normal, we do the bootstrapping, okay? And basically these are the settings that I use, and we still use the maximum likelihood. And let's hope it works. Sometimes it gives me trouble also.
Bootstrapping is the resampling our sample, right?
Yes. You also took it in the data analytics course, right?
I took it in the machine learning class.
In the machine learning with Professor Chen.
Yeah.
Good. You see, these courses are awesome. They come in handy. All right. You know what, Anna, you are a very lucky girl and you're bringing me luck. I don't know, things are running smooth. I need just to tell you that I set this up to 250 because I have a reference paper about setting up to 250. So it's not just a number that I came up with. And the only thing I would like you to do this time is to go to estimates, to scalars. Back in the time, we just hit on estimates, right? And the p-value here. But this p-value is not actually the p-value from the bootstrap confidence. So you just need to go to here, standardized regression weights. There's no p-value, but I want to see the p-value coming from the bootstrap. And over here, you need all of these to be less than 0.05. And I can see no problems so far. Do you see any problems? No, I don't see any problem.
Far away from it.
And you know what? I think Professor Tajuddini will really appreciate your effort when he knows that you are reporting your analysis for normality and you have showed him that, oh, I have the critical value is no good. I checked this and that. I eliminated maybe one or two outliers, but still I went with the bootstrapping, because usually bootstrapping is difficult, gives us trouble, but in your case, it didn't give us any trouble. Look at that. Look at this beauty. All of them are actually significant. One little thing that I would like to also check with bootstrapping is something very popular. It's the Pauling-Stein bootstrap for the model fit. Sorry, I didn't take a look at the model fit. This means nothing if the model fit is no grade. This is still below 3. These are still below 0.8. Yeah, here. This is why I tell you we need to get rid of the outliers, because maybe with getting rid of the outliers, maybe these are getting better.
It actually went up by 0.01.
They went up
by 0.0001.
Oh, only? Oh man. So there's a lot of outliers in your data set. And this is why I tell you, even though we're not going to go for the normality assumption, but the outliers needs to be cleaned up so that we can get better values over here. If you still can collect some data, I hate to ask you for that. It's okay, it's okay. You don't have to collect more data. Because I feel we have a lot of outliers in our data set, but let me check, maybe there's any other way I could do to improve these indices. Let me see here. This is below 0.08. That's good. Okay. But there's also another one, another test, as I told you earlier, this one, the Pauling-Stein test. This Pauling-Stein test is very concrete, and it should be not significant. If it's significant, it's a trouble. I hope it's not significant, but not many papers report that. It's significant, it's a trouble. Don't report it. It's not a must. Anyway, the Pauling-Stein is not a must. We have problems with the model fit. We need to look into the data and the outliers. It will give us a headache. It will give me a headache. I'm going to look into that. It will give me a little bit of a slight headache, but at least you have something now to report, and it's all good. It's looking good. Despite this being 0.004, don't worry about this. It's not a must. Not all papers, even the ones that I will share with you, they're using Bootstrap. They claim, I'm telling you, they claim that they've done the normality assumption, but that some of them, they don't even report the skewness and the kurtosis. And I don't know how they get away with all this with publishing papers, really. Anyway, yeah, let's do the bootstrapping, because it is very difficult to show the normality assumption. I think you have a lot of outliers in your data set. But at least now we got rid of that very horrible one. Be careful when you are deleting outliers. If you want to play with the outliers, even though I'm telling you, it's not easy. Leave it for me if you want. But if you want to do it on your own for educational purposes, be aware that this numbering is a new numbering, in a sense that you need to renumber these again. So I usually, in fact, I usually like to work with Excel, because with Excel, it's easier to number and renumber. So with Excel, I just put 1, you see that? And then I go into the corner and I double click. When there's adjacent columns, it will double click and it will copy. And then I go into the bottom and I say fill series, and that's it. Now I can renumber everything all over again. And based on the renumbering of this step, this will correspond to the new 159, because I think the one that we
I
deleted.
just forgot to do that after I deleted a couple. That's why it's off.
You did it?
I forgot to do it after I deleted a couple.
Yes, I know. I know. This is the first time you're doing this kind of research. I made so many mistakes and I've done so many horrible things before I come to advise you on an easy way and best to practice on doing things. So trust me, it's all right. And all this that I explained to you in 1 hour and a half, I don't know, maybe you might think I'm stupid or something, but it took me a month or so to put things together. So maybe I'm explaining it now to you in 1 month, in 1 hour only. But it actually took me about 1 month to learn all this and put all this together and learn what is this, what is that. And honestly, I learned all this. So this is one of the things that I think we should do also as teachers or human beings, to always self-learn. It's like exercising our brain, just how we exercise our body muscles. Anyway. So
and this was the CFA now?
CFA? Yeah, we are in CFA. We are in what we call it, the measurement model. So we are in the CFA.
Which is part of the CFA.
Yes. This is the CFA. The analysis we've done on SPSS is called EFA.
EFA, yeah.
Yes, exploratory factor analysis. This is confirmatory. We're confirming. That one is exploring. This one is confirming.
Okay, so the exploring we do in order to figure out like if all of the things that we asked make sense and like pre-sorted, and then the confirming we do to fix up our model.
Yeah, indeed. We are in the exploratory factor analysis. We are confirming that we have the number of factors that we are supposed to have in our research, and that we have the correct questions loading correctly on these factors. And if we don't, we have to delete them. So just how we removed and eliminated info 1. Second, actually, why did we eliminate info 1? We should see what is the question of info 1. And we should see where it was loaded highest. And we should see, in theory, is it a good fit or not, really, honestly. Also, moreover, one thing that I forgot, I want to save this. One thing that I forgot, here in credibility or something, where did we add the credibility to some of these?
Expertise.
To credibility we added, didn't we?
We were thinking about it.
To expertise, right? We said that there's 2 credibility questions that are so beautiful. Let's keep them with expertise, right?
Yeah.
Maybe if we add them, we might get a nice model fit, a nicer model fit. Here, I'm going to add 1, I'm going to add 2, but let me move them a little, and I'm going to let you go after this because I think it's too much. You've been with me. You might need to rest, do some other things in life. Research is supposed to be enjoyable, not a torture. So over here, just for us to see it. For now, let's add these 2 that we talked about in credibility, 3 and 4, right?
Yeah.
We forgot about them. Credibility 3, where's credibility 4? Here. Let's check that out. Don't forget, if you have unobserved, unnamed errors, it's going to give you trouble. All right? All right. Come here and save and run. Hopefully it won't give us trouble. Okay, 0.55 and 0.7, for God's sake, very nice loadings. We're not going to let go of that. Let's see, model fit. Reduced, which is, oh, is it better or is it worse?
Worse.
Worse, right? But this is better. Was less than 0.08, but it's actually was already less than 0.08. Okay, just last try and see. We need to get rid of the outliers, I feel, but I'm not sure still.
It's higher.
So it's better, it's getting better and better. Okay.
I thought it's not supposed to be significant.
Miss Anna, listen to me.
Oh, significant.
This is not our last, this is actually, we call it the first order model. The first order model. But this is not our model. Let me remind you what our model is. This is not actually the correct model. So even if it's not good fit, it's okay. You know why? Because our model is that parasocial is here. Where is parasocial? Parasocial is actually connected to similarity, was it? And attractiveness?
To all the others.
Yeah, to all the others? So I need to take a look at the model again. I don't remember it, but maybe we might need to, let me take a look here. Is Anna? Let me take a look. Here's another model that we can create here. We can put parasocial here. And then they are all connected to parasocial. And then it's connected to the intention to purchase. Okay, do we have time? I don't have time. I need to go. It's 3:30. Oh, and I think it's too much for you to handle right now. I want to give you some time also to explore using AMIS on your own and reproduce these results and see. I'm going to send you also some papers as promised.
Yes, that will be really nice.
For Wednesday. And please wait for me tomorrow or Wednesday. If I have time today, I promise I'll send it to you tonight.
I'm planning to, I won't make it, but I'm planning to work on it over the weekend, like Friday and the weekend.
Good. Thanks for letting me know. So I have time to send you the email.
Can you, I sent you the updated hypotheses yesterday as well.
You did send me, are you sure you sent me a file yesterday? You did, you said that, and I confirmed receiving the files. Yeah. Okay, I'm sorry that I rushed into doing the analysis for now. I will send you back the, let me put it on my agenda.
Like if you could just check the hypotheses once more, then that would be nice.
Okay, so
and, one more question. I checked like with the office and in regards to the honors thesis thing.
Okay, do you want to apply for it?
They said there's like a class I have to take, which is on Wednesdays. Do you know anything about it?
You have to take what?
They said something about, wait, let me check.
Quiz? A what?
A class.
Cost?
A class.
A course. You need to register for honors thesis other than the regular thesis. Their communication skills is so horrible. I don't blame you for not understanding. Oh, yeah.
But is that like something else than what we have? Because it says like after that we will register the course on our side for your information. It is conducted in third period on Wednesday.
Yeah, whatever. Let's put them in whatever they want to put it. Me and you, we can meet anytime we want, and we are meeting regularly on Monday. It's okay. You tell them, okay, no problem. And
That's the thing I wanted to check. So it's like just the same thing, like we're just meeting. I don't have anything else on Wednesday, right?
okay. Yes. Okay, I got you. Yes.
Because I don't have time on Wednesday. So I was like,
No
oh,
problem.
so-
Yes. If you want, you can tell them, I already meet with my supervisor on Mondays at 2 p.m.
yeah, but that's what I already know. Yeah, I will write it again.
But if Wednesday is the only possibility, it's also okay with me, because anyway, I meet with you anytime we want.
Yeah, I don't know what is Wednesday, but I will check again with the office, but then I will apply.
However, I'm not sure if the presentation should be held in that day, but I don't think so, because we need to organize the time with the other, arrange the time with the other supervisors. So let's talk about the two supervisors. I think Professor Kian or Tajuddini is really good, right? And the second professor, which professor you think you believe that he or she can be a good candidate?
I think maybe what's his name? Sorry, I'm really bad with names.
How about Professor Chen?
Chen, the machine learning professor?
Yeah.
Yeah, or I thought maybe Professor, is it Tan? Social media marketing?
Yeah. I also thought about Professor Tan. I'm not sure. Do you know that Professor Tan took a semester off?
Oh no, I didn't notice.
Yeah, he took a semester off, but I can't tell you why.
Okay.
And I don't want to put extra work on his shoulder for now.
Okay.
About his situation right now. This is why. Otherwise, I'm sure he's the bestest candidate because he's in marketing.
Yeah, that's why I thought.
I know that. I know, but I don't know. He took a semester off for health reasons, actually.
Oh, okay.
I don't know. I feel like maybe it's just good to give him a little bit of a break for now.
Yeah. Okay. Yeah, that's understandable.
Yeah. So, but if you are the customer, you are the student, we are here as employees, we do our job. This is our obligation to you guys. He is back, so he knows that he's back. If you feel, you think about it, if you feel you want Professor Tan to be part of it, then that's it. I will ask him, no problem. At the end of the day, you are the boss.
I think like he would be a good fit because of what he teaches and also researches.
Yeah.
He would be a really good fit for it. I don't know about Professor Chen, except for like machine learning class. I don't know really what he.
I think also Professor Chen is good with analysis, and I don't know. He maybe can look into this. There's also Professor Sumire, but Professor Sumire doesn't have a PhD, so I don't feel like asking her, because at the end of the day, you want to, put the list of professors who supervise your thesis. So well, how about asking Professor Tan then and get back to you? Is that okay?
Yeah, that would be good.
Okay, I'll do that then.
Then I will get the application ready and wait for your papers, and hopefully I can send you. I will try to write something down already on the weekend, and we'll send you an updated part of my thesis latest Sunday.
Okay. Let's hope also Professor Tan will be lenient in grading.
Yeah.
So also think about it. So I'm gonna let you think about it first. And
by the way, now when are the presentations? Kind of
in January, I think. But you can also ask the office. Are you free in January? But we can do it even earlier. It depends.
I thought about like I'm probably gonna be in Germany until the 15th of January.
Oh, until the 8th, we need to do it.
Until the 8th?
We can do it in late September, December. We can also do it in late December. How about you ask the office also about the start date and the end date, the range when we can do the presentation.
Okay, yeah, we do.
And please think again about Professor Tan. What grade he gave you in his class? Did you get an A?
Yeah.
Okay, then it's okay. I think you should be fine.
Professor Tajidini was the only professor so far who gave me a B. So.
Oh, really? He gave you a B? Oh,
Yeah.
man, are you serious?
I think he never gave an A. At least I don't know a person personally that got an A.
Oh, I didn't know this about him. I see. If you want to give us another list of candidates, I am all flexible. So
no, I like him because he is really like a European professor. He likes to discuss. I like that and challenge. So.
Yeah, in LSE, when I studied in London, 70 was a distinction. So I think it's the European style. So I am aware of that.
Yeah.
But it is good to follow the other teachers, how they also grade, because otherwise, yeah, you maybe learned a lot in his course. So anyway, okay, so I'll let you go now. And I will wait for your email, yeah, to confirm the, so did you confirm or you want to think about it?
With the honors thesis?
Yeah.
I'm gonna apply now, yeah.
So you want the honors thesis and you are all right with Tan and with Tajdini Sensei?
That would be my first choice, yeah.
Okay, explore these options and then I will. And what was the title of your thesis? I'll look it up. I have all your information here. I'll look it up. And, okay, I'll send an email and get back to you.
Okay, and then if you could give me the feedback on my hypotheses.
And the hypothesis thing. Okay.
And send me the papers, but that will be it.
Send papers. All this by the weekend. You are fine with that. You're flexible.
By Thursday would be amazing because then I can start working on it on Friday.
Oh, okay.
That would be amazing.
Okay. I put here a note by Thursday. All right. I promise I'll do my best.
I can also send a reminder if you want. Just drop you a quick email on Thursday.
Okay. So today we met for almost how many hours? Like 1 hour, almost 2 hours, right?
Yeah.
To 15 minutes. It takes time, right? Okay. All right. I'll let you go now, right? You need to do stuff. Okay. Take care, and I'll see you then next Monday.
Probably makes sense though to do it like weekly, right? When we're right in the middle of the analysis.
Yeah. Once we're done with the analysis, then it's all right.
Yeah.
It's Monday on 2.
Yeah. Okay.
All right. Bye-bye.
Perfect. Bye. Thank you.
Bye-bye. Take care.